Today we're going to be reviewing bar graphs and learning more about line plots and how you can read and interpret the data on a line plot. So this is a bar graph. In general, when someone decides to graph information, it's after they've collected a good amount of information and they need a way to organize that information so it is useful to them. So let's take a look at what this bar graph is showing us. It is showing us that a number of children travel to school each day using different methods of transportation. So if we look at our x-axis, which is always going to be your line going across the bottom of your graph, it's how they're organizing their graph by category. And those four categories are by bus, by car, by bike, by car, and by walking. Along the y-axis is your number of children. So your y-axis is your numbers that are vertically going up and down your bar graph on the left-hand side. It works a little bit like a number line. You're starting off with 0, and then you have numbers that increase by 100 as you go up the number line. In between, you see these little tick marks, and that's your midway point. So this would be 0, 50, 100, 150, 200, 250, 300, and so on. Before we start answering any questions, let's take a look at the data that was collected and organized about how children travel to school. One of the observations I can make is that most children travel to school by bus. I know this because this is the longest bar on our bar graph, and if you go across, you can see that 400 children travel to school by bus. Another observation I can make is that the least amount of children go to school by bike. Again, if you go straight across, you'll be able to see how many children actually travel to school by bike. So now let's take a look at the questions. How do most of the children get to school? Most of the children get to school by bus. Again, referenced by our tallest bar. What is the least common method of traveling to school? So you're going to look for your shortest bar, which is a bike. How many children travel to school by bike? Again, if you go straight across with the top of your bar, that's going to tell me 150 children. Remember, it's our midway point between 100 and 200. How many more children travel to school by bus than by bike? We know that 400 children travel to school by bus. We learned that 150 children travel to school by bike. So 150 more children travel to school by bus than by bike. And you can figure that out by subtracting 400 minus 150. And then finally, how many children are there in the group? So this you're going to do by adding up all of the number of children for each different method of transportation. 400 plus 150 plus 300 plus 200, that equals 1,050 children altogether that are in this group that were surveyed. Now we're going to be taking a look at a line plot and how that is interpreted. Another way to organize and collect data is through the use of a line plot. A line plot looks a little bit differently, but it's used in the same way. So let's take a look at this scenario and let's figure out what this line plot is really showing us. Mr. Bradley is very proud of all of the students in his science class. They all studied hard and did an excellent job on last week's science test. Everyone in the class scored an 88% or higher. The line plot below shows the score distribution. So if you notice here, a line plot is organizing data just like a bar graph. Couple of differences. First, you have your scores across the bottom of your line plot, and if you notice, it looks like it's organized almost like a number line. It has tick marks, and under each tick mark is the score that students received. rather than bars, you have X's that represent the number of students. So I'm just going to write here, X equals the number of students. The other thing I want to show you with the line plot, and this is just something to help it go a little bit easier when you're trying to analyze your data. I like to write the number of students for each score above the top. This will really help us in answering questions and quickly analyzing the data. So 4 students received an 88%. 1, 2, 3, 4, 5, 6 students received an 89%. 3 students received a 90%. 1 student received a 91%. We didn't have any students here. 2 students, 2 students, 3 students, 0. And I'm just going to fill in the rest of the chart before we get started. Before we start answering the questions, it's always a good idea to think about any observations you're seeing so far. So far, I'm seeing that 89% 6 students received, which is the highest number of students that received a score of 89%. Then we have 97%, and then there's other students that received other scores in between. So let's take a look at our first question. How many students received a score of 94%? We can go right to 94%. We have already marked that 2 students received that score. So that answer would be 2 students. What was the highest score in the class? If you notice when this line plot was set up, we started with 88% because that was our lowest score. We did list all the way up to 100% because normally test scores go to 100%. But when we think about our answer is actually going to be 98% because those are the only 2 students that received the highest score. So the answer for number 2 is 98%. What was the lowest score in the class? That would be 88%. How many students received a score in the 80s? Now we're looking to look at just a certain part of the line plot to see what data we have. The only 2 scores that were in the 80s was 88 and 89%. If we add up the number of students that received those 2 scores, we have a total of 10. 4 plus 6. So this is 10 students. How many students received a score in the 90s? Same type of question, but now it's asking us to focus only on the score in the 90s. Even though 99% is part of the 90s, I didn't include that because none of the students received that score. So now we can just add up all of the students that received the score in the 90s. We have 4, 6, 8, 11, 15 plus 2 is 17. So 17 students received a score in the 90s. How many students scored 93% or less? So for this question, we still have to include 93%, but then we also want to include all of the students that received less than 93%. So if we start with 93%, that's 2, 3, 6, 12, that's 16 students. That received a score of 93% or less. Okay? How many students are in Mr. Bradley's science class? Now it's no longer focusing on the score itself, but how many students took the test all together. So we can just count up all our totals across the top. That's 10, 13, 14, 16, 18, 21, 25 plus 2 is 27. So that would be 27 students. Okay, now we're going to take a look at this last question. I'm just going to move this up a little bit. Okay. For this last question, we have to think a little bit more about the data. Mr. Bradley decides to give each student 2% bonus points on their last test for participating in class. Explain how you can change the graph to show the new test scores. So for something like this, we're going to look at all of the percentages across our bottom, and we're going to add 2 bonus points for each. So 88 would then be 90%, 89% would then be 91, 90% would be 92. So if you see the pattern, you'll be adding 2 percentage points to each score. So when we complete our question on the bottom, you would add 2 bonus percentage points to each score. So that is one way that you can read and analyze a line plot and using the data in different ways. Another way. So now we're going to take a look at a second way of which you and how you can use a line plot to analyze data. This is another example of a line plot with data that you have to look at a little bit differently. So let's read the scenario and let's figure this out. Miss Finnegan played a social studies review game with her class. She asked each student 10 questions. For each question answered correctly, she would award the student 1 point. The line plot below shows the scores. So if you notice, this line plot looks very similar to the one that we just looked at, but the data is a little different. So first we have our title, Social Studies Review Game Scores. We have our scores across the bottom, again looking like a number line, and each tick mark is representing a different score. So similar to the other line plot, our X's are going to represent the number of students. I'm just going to jot that up there to remind myself that's what the X's represent. So before we get started, we can actually start to think about how many students received each score. So we have 1 student here, 1 student here, 2 students, then we have 3 students that scored 6 points, and then we have 5 students, 3, and 1 student. Okay? Again, doing that will help us analyze the data a lot quicker. One observation that we can make when looking at this line plot, it seems like more students scored 8 points or received a score of 8. Then we have the least amount of students received all 10 points or all 10 questions correct, 3 questions, and then 1 didn't get anything correct. And then we have numbers filled in between. So let's see the questions and how we can read this line plot. How many students earned exactly 6 points? So that's pretty straightforward. We can go to 6 points and notice that 3 students received 6 points. How many students earned less than 6 points? So it's not asking you to include 6 points, it's saying less than 6 points. So we're going to add our 2 students plus 1 in that range, which is a total of 4 students. Okay. Miss Finnegan awarded a gold star sticker to each student who earned more than 6 points. How many gold star stickers did she hand out? So again, now this is asking for more than 6 points. So in this range, which is more than 6, we have 5 students plus 3 plus 1, all all together, she's going to be handing out 9 stickers. How many students answered exactly 2 questions incorrectly? So this is where we're going to be using the data a little bit differently. We need to think about what this question is asking us. So don't forget, this line plot is representing all of the questions that were answered correctly. But this question is asking something a little different. So how can we think about what questions were answered incorrectly? Well, they're looking for how many students answered exactly 2 questions incorrectly. So we know there's a total of 10 questions. If there were 2 students that answered something incorrectly, or 2 questions rather, that they answered incorrectly, that would be a total of 8 questions. So you have a total of 10 minus 2 that were answered incorrectly. So that gives you a total of 8. So we're looking for the number of students that only answered 8 correctly instead of 10. And that's going to be 5 students. With those 8 questions. How many students answered 3 or more questions incorrectly? Same type of question. They're looking for what was answered incorrectly. So I'm going to give you a moment to see if you can solve that on your own, and then I'll give you the answer. Okay, so again, if we have 10 questions altogether, how many students answered 3 or more questions incorrectly? So that would be students that didn't get more than 7 questions correct. So 10 minus 3 equals 7. So we're looking at the range of all questions less than 7. So that's 3, 5, 6, and 7 students. So in those 2 questions, you actually had to think about what the question was actually asking you and using the data in a different way. So as you can see in this line plot, it works the same way, but then again, thinking about the questions, it can be answered a little bit differently, allowing you to analyze the data in a different way. Great job, everyone. So finally, what you're going to be doing today, you're going to be completing 2 worksheets. Both worksheets are actually in the same PDF file. So you will not see 2 separate files. Both worksheets are together. If you cannot print the worksheets, that's totally fine. You're also going to be having an attached answer sheet that you can type in your answers, that you can check against the answer key. The answer key we will be giving you tomorrow. Have fun with the line plots. Have a great day.